Welcome students to another in our Investigating Science series. Today we are in grade 6 looking at sounds. And in this session we are investigating the properties of sound. So, have you ever been in your community and you heard something playing, some music playing, whether near your house or far away from your house? You would notice that at times the music is very loud and you almost feel the sound vibrating in your windows and your doors. Okay. What do you notice if you go to the front of the house? Can you still hear the sound? What about if you went into your room and closed the door? Can you still hear that sound? And if you went to the back or the sides of your house, were you able to hear that sound? Why is that so? There's a simple explanation for that. It is because sound moves out in all directions from its source. So wherever the sound is, it moves, it travels, all right? And you can hear it in many different directions. And that is one way in which we can say the sound travels. What else can we note about that sound? So, if I should take two of these mallets, probably not hearing that loud enough, or if you have two forks at home, you could try this. Get two forks, knock it together, just knock it in the open and see if you can hear the sound. So in the open, it is in air. So did you hear the sound? Yes. Sound travels in air. What else can we note about sound? Suppose I had the same two forks and I placed them in water and I was still knocking it. So I want you to try that. Get two forks, put the two forks in water and knock it in the water. Do you think you would still hear the sound? Most definitely. So sound can also travel in liquids. And of course, if I hit this table and I put my ear to it, I can still hear the sound. So sound travels in solids. That's one thing to note. So far, we know that sound travels in all directions from its source. It can travel in air, it can travel in liquids, and it can travel through solids. Right. What else can we note about sound? So, have a listen. Did you hear that? Let's try again. Did you hear that sound? Can you describe that sound? Was it loud? Or was it soft? So that sound was soft. Now suppose I did this. What's the difference with that sound? Is it the same sound? That sound was loud. So as you can see, we can describe sounds based on whether it is soft or loud. When we make a soft sound, we may hit something gently. When we make a loud sound, we hit it very hard. So let's see if we can try that with our instrument here. So I'm going to hit this very gently. I wonder if you heard that sound. That's a soft sound. I hit the same thing, but this time I hit it harder. So it made a loud sound. So we can describe sounds based on whether it is soft or loud. How else else could we describe a sound? All right, so let's try this. These two bars. I don't remember the names, but let's see if we can figure out what's different about these sounds. So I'm hitting it hard, and I'm sure you're hearing a sound. Did you hear something different? Let's try again. And let's go. Would you say the sounds were the same? No, they sounded different. This one sounded low or lower, and that sound was higher. So this is a high pitch sound. That is a low pitched sound. So it means we can describe sounds based on the pitch. So when a sound has a high pitch, okay, we say the sound is high, and when it has a low pitch, the sound is low. So think about those persons who love to play guitars. You know, you have your bass guitar, or even when you're listening to music and you say turn up the bass because the bass is low, but it's, you know, right? And then of course you have those high pitched sounds. All right, so that is also a property of sound. It can have different pitches. It can have a high pitch, or it can have a low pitch. Good. What else can we note about sound? All right, now I have my xylophone, or something that looks like a xylophone, right? And we're going to see what sounds we get, and we're going to try to figure out why we got those different sounds. So we have this xylophone. I think these are some metal bars that are on it. All right, were those the same sounds? Probably not. So let's try 2 or 3 of them so you can better appreciate it. Is that high? Which one is high? That sounds higher. Yes, that sounds higher. Right? So, if you were trying to sing with that sound, you notice that your voice would be raised, right? So because you're moving from low pitch to a high pitch, all right? Now, if you look carefully at this instrument, you would notice that although it is the same material that is used to make the metal bars, they have what? What do you see? The metal bars have different lengths. So, by changing the length, I am changing the pitch. I am changing the type of sound that I hear. Right? So this metal bar, when I hit it, it is vibrating. It is vibrating. And depending on how quickly it vibrates, I get a different sound. So at this point, we are going to find out, we're going to do a quick investigation to find out how does the length of the vibrating medium or the vibrating object, how the length affects the pitch of the sound. So I know you probably don't have a xylophone, so we're going to try with a simple plastic ruler. So if you have a ruler, get your plastic ruler, and we are going to do an investigation. The question we're answering is how does the length, or what is the relationship between the length, okay, of our object or vibrating medium, length of the ruler, right, and the vibration that we get, how does the pitch of the sound how is it affected by the length of the vibrating medium? So let's see if we can try. So you get your ruler and you're going to ensure that you place your ruler at the end of a table. Table can work. And so say let 10 centimeters hang off, right? So you fix your ruler and allow only 10 centimeters length to hang off of the end of the table. Alright? And you're going to place your hand, your fingers right here, and you're going to pluck. You're going to pluck the ruler and see if you can hear the sound. Pluck the ruler and you're going to pluck it the same way each time. Alright? So when I change the length of the ruler, I'm going to ensure that I pluck it the same time. So let us listen again. Did you hear a sound? Look at how quickly the ruler vibrates. So we're hearing a, is it a low pitch or a high pitch? Did it vibrate a lot? Did the ruler vibrate quickly? Or was it very slow? So we're hearing a low sound, so we can say the pitch is low. Alright, so let's now change the length of a ruler and allow 15 centimeters to hang off the table. So 15 centimeters, place your fingers at the end, and you're going to do the same thing. You're just going to pluck it and see. Now look, is it vibrating faster? Can you see that? Go to 20 centimeters hanging off our table. Right? And so, what do we find happening here? Is that by changing the length of our ruler, whatever object we're vibrating, by changing the length, hear that sound, low pitch, hear that, we get a different pitch. So what does that tell us? It tells us that the length of the vibrating medium, as in our xylophone, right, will affect the pitch of the sound. And so that is a longer metal bar, that is a shorter metal bar. And so we get two different pitches. So, what have we learned today? We have learned that sounds can be soft or sounds can be loud, right? Sounds can have a low pitch and sounds can have a high pitch. And by changing the length of our vibrating medium, we can change the pitch of the sound. Okay? That's all for today. Join us next time when we continue to investigate science in the activities that we do around us. Goodbye.